Welcome. This is part 3 of chapter 3 videos on looping. In this video we will talk about the while loop. And a while loop is characterized by indefinite repetition. When the loop begins, it is not clear how many iterations or times the loop will repeat. The flow chart for a while loop looks pretty much like the flow chart for a one-sided if, in that we have a condition. If the condition is true, there are statements we execute, and when we complete the execution of the statements, which by now we call the body of the loop, we go back and repeat the test on the condition. This process continues until at some point the condition becomes false, at which point the loop is exited and we resume the execution of the statements that follow the close embrace or the end of the loop. Again, the syntax is the word while, keyword while, followed by a condition, followed by a loop body. The condition is evaluated. If the condition yields a true value, the body is executed, and the flow of control goes back to the while statement where the condition is reevaluated. The loop terminates or is exited whenever the condition becomes false. Here's an example of the execution of a while loop. If you examine this loop, we have one variable called val, and val plays the role of what we call the control variable for this loop. Whether or not this loop executes, whether or not the body executes depends upon the value of the variable val. Notice what happens every time the body is executed. Each time the body is executed, we output the value of the variable and we decrement the variable. So if the loop begins with the value 5, we expect it to be 5 and then 4, then 3, and we continue to execute the body so long as the value is greater than or equal to 0. Notice that we do execute the body of the loop when the value becomes 0, after which we do what? We decrement the 0, it becomes a -1, and at that point value is no longer greater than or equal to 0, and the loop terminates. So if we want to make up a trace table for this loop, we keep track of the control variable val, we keep track of the condition, which is this comparison, the result of the condition. We keep track of what goes on inside the body. One is the output, the other is the adjustment of the variable called val. Why don't we pull this code up and just take a look. Here we see the code that you saw before. And now we are going to notice that this variable is not required, so don't pay any attention to this. It's not required here. So let's go ahead and compile this. And now we're going to execute it. And we see the values that we indicate that you would see. I need to demonstrate this for you. Suppose we go in and we change this so that we make a mistake here. Let's suppose the mistake is going to be that we say val is equal to 0. What's going to happen? Well, let's skip that. Let's go back. Forget that I ever said that. I'm sorry. Let's get out. Let's resume. Now, the The while loop executes as few as 0 times. If the condition is never true in the beginning, you do not execute. As before, if the loop body consists of just one action or one statement, it can be eliminated. While, if you look at the flowchart for the while loop and the for loop, they look the same in the sense that they both are pretest loops. That simply means the condition is evaluated in order to enter the body of the loop. Now, in order to terminate the loop body must contain code that forces the condition to eventually become false. Otherwise, as long as the condition is true, you never leave the loop. If the condition is never changed from true to false, we have what's called an infinite loop. And here's an example of an infinite loop. I need to show you what happens when a program runs with an infinite loop. So let's go back in here. Let's make this infinite. But if we say as long as the value is less than or equal to 5, what's going to happen? Well, I start at 5, so it's going to be true. I'm going to decrease the value, decrease the value, decrease the value. So we'll see what happens. So let's see that. When we execute that, notice that this is running and the values are getting smaller and smaller and smaller. Notice what I did to stop the program. I entered Control-C. So Control-C. Most of the time hitting Control-C once will stop it. Sometimes you may have to do it several times. Okay. There are some common loop errors. One sometimes is to forget to enter a block when you have more than one statement. So if you leave that out, the scope of the loop is just this one statement here. And what kind of loop do we have if we do that? Notice that num entries, if I begin the loop, the body of the loop does not change num entries. Therefore, if I ever start executing that loop, I execute it forever. Another common mistake has to do with the comparison for equality, and that operator is 2 equal signs, not 1. Here are 2 examples. The condition num entries single equal sign 3 is always true because the value of this expression is a 3, and 3 is true. Likewise, the value of this is always false because the expression yields the value of 0. When writing a while loop, you must always remember that the condition that we write in the code is the condition for continuing the loop. It is not the condition for stopping the loop. So you must always be able to translate the stopping condition into the continuation condition. Simple example. If the stopping condition is whenever x becomes greater than 5, you want to stop, it really means that as long as x is not greater than 5, we continue. So if you negate the operator greater than, it becomes less than or equal. If you negate the operator less than or equal, it becomes greater than. If you negate the operator not equal, it's the operator equal. Now if we use logical operators, the opposite of x greater than y or y is equal to 2 is the negation of this and the negation of that. Those of you who've taken discrete understand that this is called De Morgan's law. So the negation of this is to negate the first expression, change the or to an and, negate the second expression. All right? If your stopping condition is that you fall outside of an interval, Then the continuation condition is that you are inside the interval. How do we see that we're inside of an interval? We said two things must be true. The first condition must be true, and the second condition. You must be beyond the first boundary, and you must be beyond the second. Okay. There are times when the continuation condition has to do with the ability to do input. And there's a way to check to see if input has failed. The .fail function that we have been using can tell you if the previous operation failed. Okay. Other times we can say continue, stop whenever I'm unable to read values from a stream. And we said that we can test for that. We can attempt to read using greater, and it will return a value that's true or false. Again, sometimes we want to say the stopping condition is X is odd and Y is even. How do we negate that again? We're going to change the and to an or, and we're going to negate X is odd, which means X is even, and we're going to negate Y is even, Y is odd. How do we do that? We use the remainder function to determine if something is even or odd. Divide by 2 if the remainder is 0, it's even. Divide by 2 if the remainder is 1, the number is odd. With that, we will stop.